What if one day we could ride an elevator, not just to the top of a skyscraper, but all the way into space? No rockets, no explosions, no fiery launches, just a smooth ride from Earth to orbit. This bold idea is known as a space elevator, and it could completely change how humanity explores the universe. But is such a thing really possible? Or is it still just a dream of science fiction? Let's uncover the truth behind this extraordinary concept. What exactly is a space elevator? A space elevator is a bold idea that could change space travel forever. Instead of blasting rockets into the sky, imagine a giant cable stretching from Earth's surface to space. At the bottom, it would be anchored to the ground near the equator. At the top, it would connect to a station in geostationary orbit, about 35,786 kilometers away. Elevator cars would climb the cable, carrying people and supplies into space smoothly and cheaply. The idea first appeared in 1895, proposed by Russian scientist Konstantin Tsiolkovsky, and later gained attention through science fiction. If successful, it could make space travel safer, cheaper, and far more accessible. But building something so massive comes with some of the toughest challenges in human history. The challenge of material strength. The biggest obstacle to building a space elevator is the cable. It must stretch tens of thousands of kilometers into space while supporting its own weight and the weight of climbing vehicles. Materials like steel or titanium are far too weak. Scientists estimate the tether must be 100 times stronger than steel. This is why researchers are studying carbon nanotubes and graphene. These advanced materials are extremely strong and light, making them possible candidates. The problem is manufacturing. While small amounts of nanotubes exist, creating a flawless ribbon thousands of kilometers long is far beyond our current abilities. Even the smallest defect could cause a catastrophic break. Without a breakthrough in material science, the dream of a space elevator remains impossible. Manufacturing and deployment hurdles. Even if we had the perfect material, building a space elevator would be a monumental task. How do you deploy a cable that long? Some suggest building it in orbit and lowering it to Earth, while others propose starting from the ground and extending it upward with counterweights in space. Both methods are highly complex. Manufacturing is another challenge. Billions of tons of advanced fibers would be needed, each flawless in strength. Transporting and assembling such structures in orbit would require technology we don't yet have. Even anchoring the base is tricky, since it must withstand storms, earthquakes, and other natural forces. In short, designing, producing, and safely deploying the world's largest machine would demand engineering at a scale humanity has never attempted. The threat of space. Debris. Earth's orbit is crowded with satellites, old rocket parts, and tiny fragments of debris moving at incredible speeds. A space elevator tether would pass directly through these orbital paths, making it a giant target. Even a small collision could damage or snap the cable. To prevent this, scientists suggest using advanced tracking systems that move the tether slightly to avoid impacts. Others propose designing the tether in replaceable sections so that damaged parts can be swapped out. Another concern is long-term orbital safety. Adding such a massive structure could make the space junk problem even worse. That's why space agencies are already researching cleanup technologies, such as lasers and robotic systems. Without solving the debris problem, a space elevator cannot be safe. Geostationary orbit alignment. For a space elevator to work, its top must reach geostationary orbit, about 35,786 kilometers above Earth. At this altitude, objects orbit at the same speed as Earth's rotation, appearing fixed over one spot. Without this alignment, the tether would swing uncontrollably, making the system impossible. To keep the cable balanced, engineers propose attaching a huge counterweight, possibly even an asteroid, beyond this orbit. The system must also remain stable against the pull of the moon, the sun, and solar winds. Even slight shifts could twist or damage the structure. Maintaining perfect alignment would require constant monitoring, precise calculations, and advanced control systems. Cost and maintenance. The cost of building a space elevator would likely reach into the trillions, making it one of the most expensive projects in human history. Construction is only the beginning. Maintenance would be non-stop. The tether would face constant stress from weather, radiation, and tiny space particles. Robotic climbers would need to patrol it, repairing damage before it grows dangerous. No single nation or company could afford this alone, so global cooperation would be essential. Supporters argue the investment could pay off, since launches might become 90% cheaper. Still, convincing governments and investors to fund such a risky, untested megastructure is one of the toughest challenges of all. Risks of catastrophic failure. A space elevator would be one of humanity's most ambitious projects, but also one of the riskiest. If the tether snapped near its base, it could whip across Earth, causing massive destruction. If it broke higher up, large sections might fall, damaging land or sea. To reduce this danger, engineers suggest anchoring the base in the ocean, far from cities. Another concern is security. The elevator could become a target for sabotage or warfare. Because of these risks, many scientists believe it's safer to first attempt smaller versions on the Moon or Mars, where weaker gravity and no atmosphere make failures far less dangerous. Alternative configurations. Because building a space elevator on Earth is so difficult, scientists are considering alternative versions. One promising idea is a lunar elevator, anchored on the Moon. The weaker gravity and lack of atmosphere make it much easier to build using today's technology. A Martian elevator could also be possible, supporting future colonies on Mars by moving supplies between orbit and the surface. Another option is the Skyhook, a shorter orbital tether that helps spacecraft reach orbit with less fuel. These smaller systems could serve as stepping stones, giving humanity the chance to test and refine the concept before attempting the ultimate challenge: an Earth-based space elevator. The future of advanced materials. The key to a working space elevator is materials. Carbon nanotubes and graphene are the strongest candidates. Both are made of carbon atoms arranged in special structures that make them extremely strong yet lightweight. In theory, a ribbon of these materials could support the tether. The problem is production. Right now, scientists can only make nanotubes and graphene in tiny amounts. Scaling them up into flawless, kilometer-long fibers is nearly impossible with today's methods. But research is progressing. New nanotechnology and 3D molecular printing may one day solve the issue. Other options, like diamond nanothreads, are also being explored. If breakthroughs happen, they won't just make space elevators possible. They could transform engineering on Earth, changing everything from airplanes to bridges. What this could mean for the future of space. If humanity succeeds in building a space elevator, the impact would be extraordinary. Space travel would become far cheaper, safer, and more routine. Satellites could be launched at a fraction of today's costs. Space tourism could become possible for ordinary people, not just billionaires. Industries like asteroid mining could provide resources never before available. Colonizing the Moon and Mars would become much more practical. Most importantly, it would create a permanent connection between Earth and space, like a highway to the stars. Such a structure could trigger a new era of exploration, much like ships once opened the world's oceans. While still a dream, the space elevator represents humanity's endless drive to turn imagination into reality. So, can we really build a space elevator? Not yet. The science, cost, and risks are still too great, but research in advanced materials and new designs is bringing us closer. One day, what seems impossible today could redefine space travel forever. If you enjoyed this exploration, don't forget to like, share, and subscribe to our channel for more exciting content. Thanks for watching. Until next time, stay curious and keep looking up.